All right, then on this one, we're given this is free response 2 on day 3. We're told what the derivative of f is, and we're given it in this format. And the first thing we're asked to do is find the x-coordinate of the critical point. So the critical point is where where the derivative equals 0 or is undefined. So this derivative will equal 0 at x equal 4. And then you would be undefined at x equals 0, except we're told that x is bigger than 0. So we don't have to worry about that. So x equals 4. First thing, there's our first point. Okay? Then we're supposed to determine if it's a max, a minimum, or neither. So in order to do that, we have to do a test, right? So we'll put 4 down. And let's pick something less than 4. If we pick, say, 2, in order to put that in, we would get 2 times 1/8. So that's a positive. If we were to put something bigger than 4 in, say 6, we'd get negative times 200 and something. That's going to be a negative. So our derivative switches from positive to negative. Therefore, f has a relative maximum at x equal 4 because f prime switches from positive to negative. So again, you have to write it out. You can't just point to this. The grader doesn't look at that. They look at your explanation. So point here for the max and maybe even a point for the explanation. All right. Find all the intervals on which the graph is concave down. So in order to be concave down, we have to look at our second derivative, right? When is our second derivative negative? So the first thing we're going to do is take the second derivative. Now, you could do a product rule here, but I think it gets real clunky when you do product rule. This is easy enough for us to just go ahead and distribute and have f prime of x equal to 4x to the negative 3 minus x to the 1 plus negative 3 negative 2. Maybe that'll make life a little simpler on this next part. Maybe not. We'll have to see. So the second derivative of x is negative 12x to the negative 4 minus negative 2, so plus 2x to the negative 3. Now, I want to know when that equals 0. So if I set it equal to 0, I'm going to rewrite it just to kind of see if I can have a little bit of get an idea here. So I rewrote these negative ones. Now I noticed that if I were to multiply here by x, that would go to x to the 4th, and that'd be 2x. So I'd have negative 12 plus 2x over x to the 4th equal to 0. Just trying to get a common denominator there. Now if I were to multiply by x to the 4th, that would cancel, and it would leave me with just that. So in other words, I'm really just interested in when that equals 0, when the top equals 0. And that will be when x equals 6. Okay, so you get a point for the second derivative, and you get a point for x equals 6. Now we have to justify it. We don't know if that's really a point of inflection or not. So in order to do that, we're going to, again, test it out, go to our second derivative this time. And if I put something less than 6 in there, say put 1 in, I'm going to get negative 10 over 1. That's a negative. If I were to put something bigger, say 10 in, I'm going to get 8 over, that's going to get a positive. So indeed, f has a point of inflection at x equals 6 because f double prime switches sign. And that would be a point for the explanation. Okay? So I think the trick right here would be getting from here to here to here, right? If you see that, then it goes pretty smoothly. If not, you kind of spin your wheels right there. But at least you should get that point for the derivative, the second derivative. Okay. Now, it says, given that f of 1 is equal to 2, determine f. So in other words, now we're going from the derivative up to the original function. So we're going to have to integrate. And for sure, you have to distribute. If you haven't distributed yet, you had to distribute here. We're going to say that, actually, I'll do it down here. F of x is equal to the integral of the derivative. So I'm going to write it in that format there. And so that's going to equal 4x to the negative 2 over negative 2 minus x to the negative 1 over negative 1 plus c. Okay, so definitely some simplifying is needed here. We're going to get 4 divided by negative 2, negative 2, and I'm going to rewrite that as over x squared. And then this minus and negative become plus 1 over x and then plus c. So here's my f of x. Okay, now I got to figure out what c equals. So I'm putting 1 in for x and 2 for the function. So 2 equals negative 2 over 1 squared plus 1 over 1 plus c. So 4, 3, I get c equal to 3 here. Okay, so let's put it all together. F of x is equal to negative 2 over x squared plus 1 over x plus 3. I believe they'd give you a point for integrating correctly to here, a point for finding c, and then a point for our final answer.